Look up at the night sky. What do you see? Countless pinpricks of light. These are stars. They're not just pretty lights, they're the engines of the cosmos. Stars create the elements that make up everything we know, from the iron in your blood to the gold in your jewelry. Stars have fascinated humans for millennia. Ancient civilizations saw patterns in the stars, using them to navigate and tell time. Today we know how stars are born, live and die, yet they still hold many mysteries. Stars are more than just distant suns, they're cosmic factories forging the building blocks of the universe. Without stars we wouldn't exist. The story of stars is our story, the story of the universe itself. In this essay we'll explore the life cycle of stars, starting with their birth in vast clouds of gas and dust. We'll see how they shine for millions or billions of years and witness their often spectacular deaths. Get ready for a journey across space and time. Stars are born in cosmic clouds called nebulae, which can span hundreds of light years. They're made mostly of hydrogen and helium, the simplest and most abundant elements in the universe. Inside a nebula, gravity pulls the gas and dust together, forming denser regions that grow as they attract more matter. These regions become clumps, and as a clump grows, its center gets hotter and denser. Eventually, the clump becomes a protostar, the embryo of a star. The protostar continues to grow, getting hotter and denser. When the core temperature reaches about 10 million degrees Celsius, fusion begins. Hydrogen atoms slam together to form helium, releasing enormous amounts of energy. The protostar lights up, pushing back against gravity with its own radiation. A delicate balance is achieved and a new star is born. At the core of every star, an incredible process called nuclear fusion takes place. This is what makes stars shine and creates most of the elements in the universe. Fusion happens when atomic nuclei join together to form heavier nuclei. In stars, hydrogen nuclei fuse to form helium, releasing a tremendous amount of energy. This energy travels outward from the star's core, moving through the star's layers until it reaches the surface. From there, it radiates into space as light and heat. Fusion is the star's life force. As long as there's hydrogen in the core, fusion continues and the star remains stable. This balance can last for billions of years, but eventually the hydrogen runs out and the star's life enters its final stages. Not all stars are created equal. They come in different sizes and colors, affecting how long they live. The most common stars are red dwarfs, small and cool, burning their fuel very slowly and living for trillions of years. At the other extreme are blue giants, huge and hot, burning through their fuel quickly and living for only a few million years. Our Sun is a yellow dwarf, a medium-sized star that has been shining for about 4.6 billion years and will continue for another 5 billion years. Most stars in the universe are smaller than our Sun, while larger stars are rarer. The color of a star tells us about its temperature. Red stars are the coolest, blue stars are the hottest, and our yellow Sun is in the middle. Understanding these differences helps us predict a star's lifespan and eventual fate. All stars die, but they don't all die the same way. The death of a star can be as spectacular as its life. For stars like our Sun, the end is relatively peaceful. When the hydrogen runs out, the core contracts, heating up and causing the outer layers to expand. The star becomes a red giant, and eventually the outer layers drift away, forming a beautiful planetary nebula. The core that's left behind is a white dwarf, which will slowly cool over billions of years. For stars much larger than our Sun, the end is explosive. When these stars run out of fuel, their cores collapse, triggering a massive explosion called a supernova. A supernova can briefly outshine an entire galaxy, spreading heavy elements into space. If the star was 10 to 20 times the mass of our Sun, a neutron star forms, incredibly dense. For even larger stars, the remnant becomes a black hole, so dense that not even light can escape their gravity. The death of stars might seem like the end of the story, but it's really just the beginning. Dead stars play a crucial role in shaping the universe, being the source of most elements heavier than helium. When stars die, they release these elements into space, mixing with existing gas clouds to form new stars and planets. This cycle has been repeating for billions of years, with each generation of stars adding more heavy elements to the mix. Supernovae are particularly important in this process, creating and spreading elements like carbon, oxygen and iron. The calcium in your bones, the oxygen you breathe, the iron in your blood, all were forged in stars. Dead stars also shape the structure of galaxies. Supernova explosions create shock waves that compress nearby gas clouds, triggering the formation of new stars. Black holes, especially supermassive ones, influence galactic evolution, affecting star formation and the distribution of matter. In this way, the story of stars is a never-ending cycle of death and rebirth, a cosmic dance that has been going on for billions of years and will continue long into the future.